Hello students, we will start with unit 6, that is curves and fractals. Before going and introducing this, let's have some basic info. So until now we have seen how to draw lines, circles, polygons, etc. Now to draw a line, we are having different algorithms. We have seen these algorithms. Do you remember? DDA, Bresenim, all these are line drawing algorithms. So by using these algorithms, we can easily form any kind of straight line. But in nature, the objects are not strictly following these shapes, right? The objects which are available in nature are generally having rough and curved surfaces. Now many artificial objects are also having curved surfaces. So in this unit, we will discuss how to generate different curves. Now curves are one of the most essential objects to create high resolution graphics. Now while using many small polylines allows creating graphics that appear smooth at fixed resolutions. Now they do not preserve smoothness when scaled and also require a tremendous amount of storage for any high resolution image. So curves can be stored in a much easier way and can be scaled actually to any resolution without losing their main quality, that is smoothness. And most importantly, it provides a much easier way to specify the real world objects. All the popular curves used in graphics are, we know, that specified by the parametric equation. Now instead of specifying a function, that is standard function of the form y equals to fx, the equation y equal to fy in bracket u and x equal to fx of u are used. So use of the parametric equations actually allows the curve that can double back and cross themselves. Now which is actually impossible to specify in single equation, that is y equal to fx wala case. So the parametric, and now why this equation easy, because we can change u in this depending on the distance, right? As parametric equations are easier to evaluate too. Now changing u results in moving a fixed distance along the curve obviously. Now while in traditional equation form, much work is needed to determine whether to step through x or to step through y, and determining how large a step to take based on the actual slope, right? So considering all these factors, we will see now how to generate curves. Curve generation. So we can say that for generating curve, mainly we have two methods, like use of curve generation method and approximate the curve. And approximate the curve is nothing but called as interpolation, right? It is called as it is called the approximation of curve or interpolation. So first we'll see some info about how to generate curve, the methods used to generate curve. These are the very basic methods which are already available, right? Now here what we can do is use any ready-made curve generation algorithm to draw a curve such as DDA. Now we know that DDA is basically used for line generation. So we can make use of circle generation algorithm also to form different curves. By using algorithm such as DDA, Bresenim circle generation or midpoint circle generation, we will get actual curve. Now when we are using any circle generation algorithm to draw a curve, at that time we should not draw a complete circle, right? Because we want a particular curve, but we should what we should do is only draw some part of that circle which will obviously act as a curve. But when we are using DDA algorithm to generate a circular arc, we need radius and obviously some angle theta, right, to draw a curve. So if we want to draw a curve, so suppose from point x1 y1 to x2 y2, that is of angle theta, then we have to find the coordinates of x1 y1 as the basic equation, right, that is x1 equals to center plus radius, and y1 equal to obviously comes as the yc, that is center. Now this x1 y1 will be the first point on the curve, right? Now to plot the second point on the curve, we have to use another equation. So this way we can use these equations and the given algorithms for generating. Now when we are using any circle generation algorithm, we should not use symmetry property of circle, right? Because here we have to plot only some part of the circle. After finding any particular point on the path of curve, we have to plot only that point, right, and we should not replicate it in remaining quadrants or octants. So by using either curve generation or circle generation method, we can get true curve, but this method also has some drawbacks, like we need more information than just its endpoints. Now when we scale a line, it remains line only, that is the basic property are not changing obviously. But if we scale a curve, it may behave differently, that is when a circle is scaled in one direction, obviously it acts as an ellipse. So the basic properties are getting changed. Now clipping will be difficult for curve obviously. Every curve which we want to draw in is not that simple to implement, right? And so we have to use another method to draw curves, and this another method is called approximation method or interpolation method. Okay, so we'll see interpolation method in next video.